Hello, everyone. I'm here to talk to you today about supernova. So essentially, we're going to take a presentation into a deep dive of the types of supernova, then the power, and then a little wrap up. Let's get into it. So what are supernova? They're pretty much just stars dying in a cool way. It's way more complicated than that, but that's the gist of it. So essentially, we have a star in the night sky, which you can see on this image on the left, which doesn't appear all that odd. And then suddenly, it becomes super luminous. That is what a supernova is. Essentially, the core of the star or some other process, which we'll discuss later, causes a explosion within the star that blasts a bunch of material out and also creates a ton of light. These are some of the coolest events in the universe because of just how powerful they are. Um, you can see this blast of light in the second frame and then gas spreading out away from the supernova in the last 6 frames. With this, the supernova also creates some of the heavy elements that we need for life. Other things can't really make heavy elements past iron. So all of our super heavy, like gold to uranium type elements, are formed in supernova, which is super sick. So there's a bunch of types of supernova. We're going to start with type 2. Yeah, a little out of order, but type 2 is not as cool as type 1 in my opinion. So type 2, with essentially a supermassive star starts fusing past helium and then gets to carbon and starts fusing the carbon in its core. Essentially, you start fusing hydrogen outside and you create rings of cores that are super hot and fusing elements together. This fusion creates a ton of energy, and these stars are really, really big, like 10 to 100 times the size of our sun. Um, and then once you reach an iron core, you can't fuse anymore because you can't get any more energy from that fusion. So once you hit that, you have to either stop at your iron core, but the star is so hot that it pushes on all of those iron elements until all of the electrons combine with all the protons within that core, and you get a neutron core. This core shrinks rapidly. It shrinks a whole ton really, really quickly. And the rest of the star explodes with this. And that is when we really can see the supernova. We can see supermassive stars that are in the process, but the supernova is when that iron core collapses. You can see in this next diagram, we get an iron core with a bunch of other elements all fusing outside and dropping elements into the center. And then eventually we collapse into a neutron star. And if you have a dense enough core, you can collapse from a neutron star or even further into a black hole. But most of the mass of the star gets blown away in this supermassive explosion, as you can see in this last frame. The other type of supernova is a type 1 supernova. These are when a white dwarf, which is a dead carbon core of a star that wasn't massive enough to go supernova in its lifetime, accretes material until it reaches its mass limit where electron degeneracy pressure can't hold it up anymore, and all of it simultaneously fuses in a huge flash of bright light. So the remnants of these supernova, actually white dwarf supernova leave no remnants, but core collapse supernova can leave neutron stars, seen on the left, or black holes, seen on the right. Both of these are super sick, some of the most powerful things in the universe, but we're talking about supernova. So let's talk about their power. So 1A supernova is about 10 to the 44 joules of power. A core collapse supernova is about 10 to the 46 joules of power, but that makes no sense in our context. So let's look at how much a joule is. Your average punch is 100 to 150 joules, which is a lot. Lightning is about a billion joules, which is 10 to the 9. Our largest nuclear weapon ever, Tsar Bomba, was about 10 to the 17 joules. So in order of our largest bomb ever created on Earth, that'd be 10 to the 27 of them for a 1A supernova, or 10 to the 29 for a core collapse supernova. And for reference, there are about 10 to the 17 grains of sand on Earth. So that's really, really powerful, way more powerful than anything in our solar system. So yeah, that's it. Essentially, supernova are super cool, super powerful. some of the events that create some of the materials we need for life on Earth. And yeah, thanks for watching.